Now we will talk about relative refractive index. In the previous section we studied about absolute refractive index where ray was traveling from vacuum to a medium, vacuum to glass, vacuum to water, vacuum to diamond, but light can travel from any optical medium to any other optical medium. So whenever light travels from vacuum to an optical medium, that refractive index is absolute. But if light is traveling from optical medium 1 to optical medium 2, it can be from glass to water, water to glass, diamond to water, diamond to glass. It can be any two medium. So whenever light travels from optical medium 1 to optical medium 2, refractive index of second medium with respect to first medium is called as relative refractive index. So remember, vacuum to a medium is absolute value. One medium to another medium will give you relative value. So relative refractive index can be given by mu 2 of 1, where this indicates light traveling from optical medium 1 to optical medium 2. We studied that refractive index of medium with respect to vacuum was given by, since light was traveling from vacuum to a medium, we took speed of light in vacuum to the speed of light in medium. In the same way we can take refractive index of 2 with respect to 1. Light is traveling from 1 to 2. So I will take over here the ratio of speed of light in medium 1 to the speed of light in medium 2. So mu 2 of 1 ka value will be V1 by V2. Remember, whether we talk about absolute refractive index or relative refractive index, both are the ratio of two same physical quantity, that is speed. So this refractive index is a unitless constant. It is a unitless constant. It has no unit. So when light travels from vacuum to a medium, it is absolute value, always greater than 1. But when light travels from one optical medium to another optical medium, it will be a relative value, and this relative value can be more, less or equal to 1. I'll explain it later. As of now, mu 2 of 1 ka value will be V1 by V2. So let's say in medium 1, the wavelength of the wave was lambda 1 and the frequency is f. Now we know that when light travels from one optical medium to another optical medium, the frequency will never change. So when it goes from when it goes into the second medium, the wavelength becomes lambda 2. Cancelling f over here, it will be lambda 1 by lambda 2. So we have now relation mu 2 of 1 can be written as V1 by V2, or it can be written as lambda 1 by lambda 2. One more important relation I want to explain, that this mu 2 of 1 can be written as V1 by V2. Mathematically I can write it 1 by V2, 1 by V1. That is, mathematically I have written, remember, V1 by V2 can be written as 1 by V2 whole to 1 by V1. So what I am doing over here, that you see this is V2 and V1. Instead of 1, I am writing C over here. It is mathematically correct. So this C by V2, remember, C by Vm is absolute value. So C by V2 can be simply written as absolute refractive index of mu 2. C by V1 can be written as absolute refractive index of mu 1. Remember, mu 2 of 1 can also be written as mu 2 by mu 1. This is the proof I have given to you. That means, example, refractive index of glass with respect to water can be written as mu g by mu w. Refractive index of glass with respect to diamond can be written as mu g by mu d. But if I give you the value mu g by mu w ka value, it is 1.5, 1.33. It will be approximately equal to 1.1. That means refractive index of glass with respect to water is 1.1. We got greater than 1. But refractive index of glass with respect to diamond, if I put the value, diamond ka refractive index is 2.42. Somewhere it will give you 0.6. That means here the relative refractive index of value can be greater than 1 or it can be less than 1. But remember, absolute refractive index will always be more than 1. Here, what do we mean by this statement, that refractive index of glass with respect to water is 1.1. That means when light travels from water to glass, the speed of light in glass is 1.1 times less. 1.1 times less as compared to speed in water. If light travels from diamond to glass, the speed of light in glass will be, come on tell me, it will be zero point 0.6 times. It will be 0.6 times the speed in diamond. That means speed has increased. Speed has increased. So while going from water to glass, it is value more than 1. While going from diamond to glass, it is value less than 1. That means diamond का refractive index is more than glass. We can see 2.42, and water का refractive index 1.33 is less than glass. So what do you mean by this statement? From this relation, this mu2 of 1, mu2 by mu1 can be written as v1 by v2. You can see that mu2 is inversely proportional to v2 and mu1 is inversely proportional to mu1. That means greater the value of refractive index, lesser will be the speed of light in that medium. Lesser the value of refractive index, greater will be the speed of light in that medium. From this concept, we get the idea of optically rarer medium and optically denser medium. So what do you mean by optically rarer medium and then optically denser medium? Remember, it is just a relative value. Whenever we compare two medium, in one medium the speed will be less, so other medium the speed will be more. So the medium where the speed of light is more, remember, the medium where the speed of light is more is said to be optically rarer, and the medium where the speed of light is less is said to be optically denser. Remember, speed is inversely proportional to refractive index. So velocity more, so refractive index का value will be less. Here velocity less, so refractive index का value will be more. That means if I say refractive index of second medium is more than first medium, it means refractive index of 2 more than first medium explains that the speed of light in medium 2 is lesser than the speed of light in medium 1. That means greater the refractive index, lesser will be the speed, denser will be the medium. So whenever we compare two mediums, the medium having greater refractive index will have lesser speed, is said to be optically denser. The medium having lesser refractive index will have greater the speed of light, is said to be optically rarer. So optically denser and optically rarer are just a relative concept, because if I talk about glass and water, glass and water, glass is optically denser than water. But if I talk about glass and diamond, so glass is optically rarer than diamond. Remember, these are the two relative values. Thank you.